Hello everyone, welcome to my channel. In this video, I'll be demonstrating my travel booking microservices platform, a production style DevOps project deployed on Amazon EKS using modern cloud native tools and best practices. Let's get started. First, the entire AWS infrastructure was provisioned using Terraform. This includes the VPC, networking, IAM roles, Amazon AKS cluster, and Route 53 DNS configuration, making the infrastructure fully automated and reproducible. The application is built using a microservices architecture. This application with separate services for the front end, user management, search, booking, payment, and notifications. Each service is containerized with Docker and deployed to Kubernetes using mchat. For CI/CD, I deployed Jenkins inside the Kubernetes cluster using M. This is our Jenkins. Using M, the pipeline runs on dynamic Kubernetes Pod Agents. So this pipeline runs on Kubernetes Pod Agents, which are created only when the pipeline starts and automatically terminated after the build completes. This provides a clean, scalable, and efficient build environment. So whenever code is pushed, Jenkins is triggered, which creates Docker images, pushes them to the container registry, which is ACR, packages the mchats, and deploys the latest version to Amazon EKS. So here you can see the Jenkins pipeline successfully completing all stages. This is the Jenkins pipeline here. So you can see it. To update the image tags and deploys the latest mchat. So next I will show you the Kubernetes cluster where all the application pods are running successfully. Now let's check the application cluster. So we can see all our applications are running. Okay, we'll get back to this. Now let's test the application. So I'll register a new user, log in, search for available flights, book a ticket, and complete a payment. Finally, I'll open my trips page to verify that the booking was successfully created. Then to confirm that everything is working, correctly, I'll connect to the MySQL database running inside Kubernetes and query the user. We have the documentation for Postgres database here. Now I'll query the users, bookings, and payment tables. As you can see, all the data has been successfully stored in the database. Then finally, for observability, I implemented Prometheus for metric scraping, then Grafana for visualization, and Alertmanager for setting alert rules. Now let's test the application. Let's see if our app is running. So you can see our app is running. Now let's test the application. Okay, I'm already logged in with this user. Okay, so let me book another flight. I booked some already. So let's book another one to test our application. So this is the flight. let's just book a random flight. Let's just book this. And to confirm. Okay. Let's just input our demo card number. So this application works like a real-time travel booking application. It basically works as a real application. So here we can book another trip, and we can also book an hotel. So these are the trips that I booked. Okay, let me cancel one. So let's just cancel this because I want to check them through the Postgres database. So we cancelled. So we have one flight cancelled, 4 completed, and let me book a hotel. Okay. Okay, so now let's test this from database. Now let's test. I have all the documentation for that in here. So this is run a single quick code. So let's run a quick code. So let's run this first. Okay, so we can see the users that we have here. We have only one user, which is this, which is the user I'm logged in as. Still here. That's what we have here. Still here. This is the user I'm logged in as. Okay, now let's create another. Okay, so we can open an interactive Postgres shell using this command. So let's try it. So we are inside the Postgres shell. Now we can run different commands. So there we can list all database. So let's list. So this is all database that we have. We have a database for booking, notification, payments, and all. Let's create another. Okay, let's see registered users. let's say registered users. So this is the registered user that we have. Let's check. Let's create another. So let's see your flights. So these are all the flights that we have. Let's check. So these are for the hotels. So let's just check one. Let's check hotels from database. Then now let's see all bookings. Let's check. See all bookings. Okay, this is not loading. Okay, these are all the hotels we have. So let's see all bookings. So these are the bookings I have. So let's check. Let's put another information. So let's check cancel booking. I cancelled one. So let's check from here. So we have how many bookings? 1, 2, 3, 4, 5, 6. We have 6 bookings. 5 completed, 1 cancelled. So these are the 5 bookings. We have 1 cancel booking. So let's check for cancel. For the cancel booking. So this is the cancel booking that we have. So you can see the type flights, the total amount $302.33. That's what we have here. This. So basically this app works like a real-time travel booking application where you can book flights, pay for tickets and all. Is there anyone left to pay? So that's just all for it. Okay. So this project demonstrates my experience with AWS, Terraform, Docker, Kubernetes, Helm, Jenkins, Amazon EKS, Route 53, AWS Load Balancer Controller, MySQL, Prometheus, Grafana, and ELP stack by implementing a complete end-to-end CI/CD pipeline for a production-style microservices. So it also uses metric collection. So let's check. We have some metrics collection. So let's go to metric. So from here, see some Prometheus queries. So we can check our target up. Okay, let's try to check this from Prometheus. So these are all the targets I have set. Let's check another one. So show all travel booking targets. Let's check all travel booking targets. And the namespace travel booking. So this is it. So these are all the targets. Travel booking namespace, payment booking, user service, notification, and search service. Okay. Let's check HTTP request handled by user service. Let's check this. So these are all the HTTP requests handled by user service. Let's check another one. So for search service is same thing. Okay, let's check for booking service. So these are all the requests handled by booking service. Let's check for successful payments using Prometheus queries. So these are successful payments. We have 5 successful payments, which is exactly with what we have here. 5 successful payments, 6 payments, 1 failed. Check pod restart container, pod restart counts. So you can see all our pods are running and we've not been restarted from this. So you can see here we start 0. This is what we have from our Prometheus queries, 0. So that's all for this demo project. So we have Alertmanager for setting alert rules, Grafana for visualization. Okay, let's check Grafana. This is our Grafana dashboard. Let's go to our travel booking namespace. This is our travel booking namespace. So how to compute resources. So this is for visualization. We have Jenkins for the CI/CD, Prometheus for querying metrics, and our application.